Assalamu alaikum. Welcome to my channel. Welcome to my channel, JAHANGIR'S Science School. JAHANGIR'S Science School. Today I am going to discuss about describing motion. Describing motion. First we have to learn about what is rest and then what is motion. Rest and motion. Rest and motion. If any object does not change its position with surrounding environment with time, then it is said to be the object is at rest. So, if an object does not change its position with surrounding environment with time, then it is said to be rest. On the other hand, if any object changes its position with surrounding environment with time, then it is called motion. So there is no absolute rest in the universe because everything is in motion. So that's why there is no absolute rest or absolute motion. All rest are relative, all motion are relative. All rest are relative and all motion are relative. So if any object does not change its position with surrounding environment with time, then it is said to be the object is at rest. Then it is said to be object is at rest. Object is at rest. On the other hand, if any object changes its position, changes its position with surrounding environment with time, then it is said to be in motion. So there is no absolute rest or absolute motion. All distance and displacement. So welcome back to my class. Distance, total length covered by an object irrespectively to its direction is called distance. So if any object changes its position continuously, then without considering direction, the total path covered by an object is called distance. So distance, the total length or path covered by an object irrespectively to its direction is called called distance. On the other hand, displacement, the total length covered by an object in a particular direction, is called displacement. So the total path covered by an object in a particular direction, is called displacement. So distance is a scalar quantity and displacement is a vector quantity. Remember, distance is a scalar quantity because it has no direction, only magnitude. On the other hand, displacement has particular direction. That's why displacement is a vector quantity. So say this one is your home, and this is the position of your school. You can go to your school in following any path. But if you go to your school in a straight line, then it is called displacement. So this one is the displacement, and this one is the distance. So you can follow any path, distance. So this one is distance. On the other hand, A to B, say this one is your B is the position of your school and A is the position of your home, and you have a close friend X and another friend Y. Another friend P and position of home is Q, another friend. So A, X, Y, B is distance. A, X, Y, B is distance. So total path covered by you irrespectively to its direction is called distance. But A to B is displacement. So remember, distance is a scalar quantity and displacement is vector quantity. Now speed and velocity. The rate of change of distance, the rate of change of distance with time is called speed. On the other hand, the rate of change of displacement, the rate of change of displacement with time is called velocity. So speed equal to distance divided by time taken, and velocity equal to displacement by time taken. By time taken. Time taken. So speed is a scalar quantity, displacement is a vector quantity, because vector has particular direction. So remember, speed is a scalar quantity, scalar. Another on the other hand, velocity is vector quantity, is vector. Remember, vector quantity, because it has both magnitude and direction. Now, a distance time graph. Time graph. When we plot a graph, we should remember in y-axis we should put dependent variable. So distance is dependent variable, unit is meter, and time second, unit is second, and time is independent variable. So if distance time graph is a straight line, then it shows uniform speed, uniform or constant speed, same thing, constant speed. We can calculate speed by calculating gradient. Remember, gradient, change in distance, that means change in y-axis, here change in distance, delta means change, and time. So how we can get time, change in time? By this one is the delta t, and this one is change in distance. So remember, speed equal to gradient also known as slope of the distance time graph, So remember, speed v equal to change in distance divided by change in time. Remember this formula, change in distance divided by change in time. Okay. So distance time graph if distance time graph is like that, distance in the y-axis, time in the y-axis, if it is curved one, then it is non-uniform increasing speed. So figure 2, non-uniform increasing speed. That means accelerating. That means accelerating. If we want to find out the speed in a particular time, first we have to draw a tangent. Tangent is a straight line. Which touches at a particular particular point, this point. Then, so speed equal to gradient of the tangent drawn at a particular time, So remember, speed equal to change in distance divided by change in time. So what is the unit of speed? unit of speed is meter per second. Unit of speed is meter per second, because speed equal to distance divided by time. Unit of distance is meter and unit of time is second. So meter per second. The rate of change of distance is speed. So speed equal to distance divided by time. Unit of distance is meter, unit of time is second. So meter per second is the unit of speed. If a distance time graph is a curve like that, then tell me what type of motion represented by this distance time graph. Here gradient of the graph decreases with time. Gradient represent speed. So non-uniform decreasing speed, because the gradient of the graph decreases with time. Look at the graph here. Gradient, initially gradient is higher, then gradient of the distance time graph gradually decreases. That's why non-uniform decreasing speed, that means decelerating. If distance time graph is like that, it shows the rest, the object is rest or stationary, at rest or stationary, because the gradient of the graph is zero. Gradient of the graph is zero. Gradient represents speed, so there is no speed, so that's why at rest. Remember, if the distance time graph is horizontal with time axis, then it shows the object is at rest or stationary. At rest or stationary. Now if distance time graph is like that, in y-axis distance, in x-axis time, downwards, then it shows the object moving backward, the object moving backward with constant speed, moving backward with constant speed. Why moving backward? Because look at the graph, distance time graph. With increasing time, distance decreases. That means it returned back its original position. And this straight line represents constant speed. And downwards, that means decreasing speed, distance represent moving backward. But if distance time graph is like that, then tell me what type of motion is represented. Moving backward with decreasing speed. Moving backward with decreasing speed. Decreasing speed, because the gradient of the graph decreases with time. Look at this diagram, this graph. This graph is most important. Look at the graph. Tell me in the comment section what type of motion represented by this graph. Tell me what type of motion represented by this graph. Tell me what type of motion represented by this graph. Moving backward with increasing speed. Moving backward with increasing speed. Moving backward with increasing speed. Why increasing speed? Why increasing speed? Because the gradient, initially gradient is 0, so initially at rest, then gradient of the distance time graph increases with time. That's why increasing speed. And moving backward because distance decreases with time. Distance decreases with time. That's why it shows so if you think this video is helpful for you, then subscribe my channel and press the bell button and share my videos with your friend and family. Thank you very much.